All right, what else we need to learn is how to sketch polynomials by hand. It's just going to be a sketch. So these are our steps, but when you're sketching, you cannot use your calculator because we won't be having a calculator. So we skip this if sketching. And that's what we're doing today. We're just sketching. So our leading coefficient is if I multiply all of these out, like I had to on the last page right here, if I multiply all of them out, my leading coefficient is my highest term, is the coefficient of my highest degree, my highest term. So here it is x cubed, but we don't want to multiply it out every single time because this takes a good amount of time. So we're just going to look at the coefficients and their multiplicities. So x times x times x. So on this one, my degree is cubed because I have 3 x's. But before I even get here, we could have gotten that from this. I have 2 x's here and 1 x. It's a little confusing. That's why we're going to work a couple of them today. So here on our leading coefficient, if I multiplied all 3 of these out, just like on that last example you saw, it'd be x times x times x. So it'd be x cubed. If there happened to be a 2 here, then it'd be 2x cubed, and my leading coefficient would be 2. But here, our leading coefficient is just 1, and our degree is 3. So that helps us find our end behavior. Look, now it's flipped again. Now, this is saying what is the left side doing? Because that's when x is negative infinity, negative numbers, left side of my graph. And what's positive? So this is the left side, and this is the right side, and this is the up and down. It's just switched from how it was written yesterday. People write them all different ways, so you just got to get used to seeing them in different ways. So if my leading coefficient is positive, the right side of the graph goes up, positive. Up. If my degree is odd, then the left side of the graph does opposite, odd opposite. So that means this one goes down. Okay, my zeros, set each of these equal to 0 and solve. So x minus 4 equals 0, x minus 2 equals 0, and x plus 3 equals 0. So I get 4, 2, and negative 3. Multiplicity, all of my exponents are 1 on my parentheses, so my multiplicities are all just 1, which means they will all just cross. So all my zeros, negative 3, 1, 2, 3, negative 3, 2, and 4. And I'm just crossing through all of them. My y-intercept is a nice one, so you know you're on the right side of the graph. Always plug in 0 and see what you get out. So y-intercept, plug in 0, so 0 minus 4, 0 minus 2, and 0 plus 3. So that's just negative 4 times negative 2 times 3. So that's 8 times 3, that's 24. I know we are sketching, but we know this exact point. So 0, 24 needs to fit on this graph. So there's, looks like a 10 by 10 graph. So I'm going to count by 3s so that I can make sure I hit 24. So 3, 6, 9, 12, 15, 18, 21, 24, because I know that is a point. So to sketch, you start with your end behavior. It's coming down on the left. So then I cross through negative 3, cross through negative 3. I have to at least hit this y-intercept, if not go higher. So the problem with sketching is that we don't know the maximum. I could go higher than this. I do not know. I'm sketching. We do not know max and mins. But I do know I need to turn around and come through this number again. So at some point in between these two zeros, I need to turn around and go the other way. And again, we're crossing through at 2. Luckily, this first one, we just crossed through all of them. And again, I have to turn around somewhere in between these two zeros because the end point is up here. It can go down far. It can go down just a little bit. I don't know. This is a sketch. This is not accurate. I would have to graph it in Desmos or a graphing calculator to be able to find the max and mins. But I know the general shape is this. It crossed through all of my zeros. The left side's going down, the right side's going up, and I have this y-intercept. Okay? Domain of range, since this one's going left forever, negative infinity. This one's going right forever, positive infinity. Down forever, negative infinity. Up forever, I apologize, positive infinity. If you want it to, after you sketch it, don't look it up before because this is going to be a non-graphing calculator part of on the test on Friday. So you can look at it after you graph it and see where it goes. So I was wrong. My maximum is higher than my y-intercept. Didn't know. It was just a guess. And this was at -6. And I sketched mine at, hey, around -6. -3, -6. That's really good. That was just a guess. All right. And then we'll do another one. So we're going to do 3 of these together. And then you're going to have 8 to do on your own. So work together, help each other out on this. Leading coefficient, again, there's just x's. I wish I had another number in there so you could see it. But x, this one's being squared. So x times x squared times x. Don't forget those exponents too. So my first term would be x to the 4th if I distributed these all out, which I don't plan on doing. But my leading coefficient again is 1. My degree is 4. This is the left side because that's when x's are negative. This is the right side. Since my leading coefficient's positive, my right side goes up. Since my degree is even, my left side also goes up. Even, they do the same. Even the same, odd opposites. Sets each of these equal to 0 and solve. I like to write mine in order, especially when they do different things. So this is going to be -1, +2, +4. So x equals -1, +2, +4. Multiplicity of this first one was 1. The second one was 2. The third one is 1. So -1, multiplicity of 1 is a cross. 2 is bounce. So, I need my equation. Y-intercept, plug 0 into your equation and solve. So 0 going. 0 plus 1, x minus 2. Don't forget the squared or it's going to be wrong. 0 minus 4. That's supposed to be 0. So this is just going to be 1. Multiplying anything by 1 is just 1. -2 squared, make sure you put it in parentheses because you get a +4. So -16 when you multiply them all together. Again, this is 10 by 10. So we're going to have to at least count by 2s. So -2, -4, -6, -8, -10, -12, 14, 16, 18. So 0, -16. My zeros, -1, 2, and 4. 2 and 4. They both end up. We're crossing at 1, bouncing at 2, and crossing at 4. This is all the information I know. This is just a sketch. So starting up, I'm crossing through 1. I have to go all the way down to this -16. I could go further. I could stop there. I don't know. This is where I'm guessing. This time I'm just going to go a little further, just as a guess. Then I'm going to go up. I am bouncing. So think of the quadratic equation where it won't cross. This one's like a negative quadratic equation. So I'm bouncing off of that one. I have to turn around somewhere and get back up here. So I don't want to go down too far if I'm turning around in 2 spaces. But again, this is a guess. This relative min, absolute min, I don't know. I am guessing. And then back through that one. So here's my cross, bounce, cross. Domain, negative infinity to positive infinity. I spoiled it yesterday. Polynomials are always negative infinity to positive infinity. Range, this is where, again, it's a guess. So I'm just going to put a question mark because I don't know. It's whatever my absolute min is. You would find it given a calculator, but not given without a calculator. So it's the y value of your absolute min, which I'd need a calculator to find. But we do know it goes up forever. So question mark to infinity. If tomorrow when we're given a calculator, we'll know this question mark. Graph it, see how you did. Were you close? When I put it in Desmos just to see how I did, it bounced. My x-axis was all right, cross, bounce, cross. And then my y-intercept was not my lowest point, which I had right that it wasn't the lowest point, but I didn't extend it on the left, not the right. And then this went down to -5. But again, you don't know your mins, you're just guessing where they turn around. I went down to -4, so not bad. Not a bad guess. All right, last one. Sometimes they're not factored for you, so you have to factor them. So let's factor this, put it in factored form. So our greatest common factor is x cubed. So pull out x cubed, and what's left is -2x plus 3. Okay. My leading coefficient, well, if it's already all multiplied out for me, I don't really need to look at the first numbers. This is going to tell me my degree and my leading coefficient. Leading coefficient -2, degree 4. But if you're only looking at the factored form, you need to multiply the first two out. So that's how you know you're looking at -2x to the 4th. Here's the left side. Here's the right side. So the right side is going down. Now that this is negative, it's going to go down. Right side go down. And the left side's going to do the same thing because they're even. So the left side's also going to go down. Even, the same, odd opposites. So we have x cubed equals 0. So that's just x equals 0. So that's 0 is 0. Multiplicity of 3. The effect, this is your first cross flatten, just like the cubic. And then -2x plus 3 equals 0. So -2x equals -3. So x equals 3 over 2, or 1.5. Especially since we're graphing, I'll put it into a decimal. If it was the 0.333, like if it was 2 over 3, I'd still make it into a decimal because you're graphing. This multiplicity is 1, so this will just cross. So at 0, I'm cross flattening. And at 1.5, I'm just crossing. And they need to end at down. So I end down. Oh, y-intercept. 0, 0. Plug 0 in, 0, 0, that's 0. Oh, I already knew that. So starting down, cross flatten. So as you cross, you flatten out, just like the cubic. So it's not just a direct cross, you have to flatten a little bit as you cross. So cross flatten, I have to turn around somewhere. I don't know where, I'm guessing. These are really close, so I wouldn't guess too far apart, but I just have to turn around somewhere and then go down. Domain, still the same, -infinity, positive infinity. Range, -infinity to question mark. We don't know, but it is a bracket. Whatever the y value of my absolute max is. Okay, so that's how you sketch polynomials. Now go ahead and get your classwork done.